Hello, we are here to discuss a proof of concept to test online garbage collection on the container registry. My name is João Pereira, I'm from the package team, and Sofia is here as well. I've put together a proof of concept. Let me share my screen. All right. Can you see this?
Yeah.
So this is the MR. The code is in really bad shape, as I say here, but the intention was just to try to make sure that the recipe for the tests would work and see how can we make this compatible with GitLab CI pipelines and ideally the QA tests as well. So I've started to write down some documentation. For this, maybe you can go through it because it's small enough to understand it. As background, it is important to look at the online garbage collection specification so that you have a good overview about how online garbage collection works on the registry. We provide some background information as well, so even if you don't have a in-depth knowledge about the registry, you should be able to get a sense of how it works just by reading the spec. And basically the idea was to create a tool that could generate a bunch of artifacts, namely repositories, layers, images with multiple tags, and manifests as well. And the way that I did it is with Go, I've built a tool that is able to do this. And the first thing that it will do is generating repositories. We will only use an hard-coded set of repositories, two of them, namely A and B. This will live under a sub-repository. We can use the GitLab CI predefined environment variables for this. So the repositories will always be the CI registry image. So if I'm on the GitLab container registry project, that will be this portion of the path. Then appended with a suffix of online GC tester so that all repositories for testing are under this prefix. And finally, another random prefix that will have the pipeline ID for each pipeline, because the idea is to trigger this based on some commit, some change. So we will have a CI pipeline. And the only way to make sure that the artifacts will be isolated from each other across pipelines is to use a sub-repository that is related to that pipeline. So if we place both A and B under this path on the container registry, we can be sure that for each pipeline, A and B will be unique and there will be no relation with others that were created for other pipelines or maybe other tests. So that's why we do it. And finally, jobs, the tests can be separated in multiple jobs and stages in GitLab CI. And the way that I did it here for this proof of concept is that as I build the context, like the list of layers, the list of images, their tags, all that information, when I'm done with processing, I write down that information to a file in the file system so that the subsequent jobs and stages can read that file to get the information that was created on previous runs. So we can do that easily by using CI caching. So we can cache that file and make sure that it is propagated across jobs and stages. And for brevity, from now onwards, whenever you see prefix, we mean this whole thing. So the first thing to do is generate layers, and to make sure that we have a deterministic behavior, we need to make sure the layers used for the tests are unique. That means that no other images on the registry will be using the same layers. except the ones that we are building here. This is important because layers on the registry are shared across images. And if we want to trigger the garbage collection of a given layer, we need to make sure that we know all the images that are using that layer. Otherwise, the layer may end up not being deleted because there is some image in other repository, maybe even a repository from a user if we are testing this against a live registry. And the behavior will not be deterministic. So the first thing that the tool will do is generate a set of layers. Right now it's hard-coded to generate 5 layers. They are unique and randomly generated, and they have 1 megabyte in size. There is no specific reason for 1 megabyte. The size is irrelevant for asserting the behavior of online GC. We just need to make sure that they are small enough to be fast, pushing and pull, but not so small that there is a risk for them not to be unique across builds, because the random data used to generate them was not that big. So 1 megabyte should do it. And when we generate the layers, we name them with L, L1, L2, L3, L4, and L5. And the tool will generate these and save them to the local file system of the runner or your local machine if we are running this locally. And finally, internally, they are not referred to as L1, L2, L3, L5, and so forth. They are referred using the checksum digest, which is a compression of the layer file using the tar-gzip algorithm, and then getting the hash of that tar-gzip file will give us the digest of the layer that we will see on the registry once the image is pulled. But for simplicity, we will refer to layers as L1, L2, and so forth. The digest is only important internally for the test tool and the registry, but we will see them printed on the logs soon. Yeah, this I already said this, and internally the tool will keep a mapping between the name of the layer that is known to us and the digest that we will see on the registry side. So for the images, we will generate 5 of them. And here in this table, we can see the relationship between those images and the layers. So for example, image with tag 1.0.0 in repository hey references layer L1 and L2. Then we have tag 2.0.0, which kind of simulates like the next version for 1.0.0, which added another layer L3 on top of the L1 and L2. And then on the same repository, we have tag latest, which also mimics a usual behavior, which is giving the tag latest to the highest semantic version image that you have. So in this case, both tags 2.0.0 and latest point to the same manifest, which has the same layers L1, L2, and L3. And then we have another repository B. This one has a single tag, and it references L1, L4, and L5. And finally, a pending tag in the A repository, which only reference layer 1. So these images, the composition of these images are hard-coded. What changes is the content of the layers. But for us, using the tool, it's always L1, L2 for this tag, and so forth. So here we can see that correlation. I chose this correlation because it will give us the possibility to test multiple scenarios, like, for example, deleting the tag latest and making sure that neither L1, L2, or L3 were deleted, because that is still tag 2.0.0, which references those same layers. So we will see that later on. I already explained this. The pending image here will not be pushed to the registry right after. We will use that on the test stage to simulate a tag switch, but we will talk about that later. And then we have the correlation between images and manifests. Just like layers, manifests are referred to using their checksum digest, but for the sake of simplicity, we will use the same notation. So from M1 to M4 to refer to those manifests, and you can see the correlation between the tag and the manifest that it points to. So we know that, for example, tag 1.0.0 in repository A points to manifest M1, and therefore we know that manifest M1 will reference layer 1 and layer 2 and so forth. So looking at these two tables, we can make that relationship to validate the tests. And as I said, what 2.0.0 and latest point to the same manifest M2. They are composed by the exact same layers. They have the same manifest. And finally, the last thing to be generated are the Docker files. And basically, the Docker files are very, very simple. They are built from scratch, so they don't have any data. And then for each layer, we use an instruction called head. I actually should add an example here, but basically, this is how these Docker files look like. And if I go here, basically, we would have head L1 here, head L2, and by doing this, referring to L1 and L2, this would be the Docker file M1, which points to layer 1 and 2, and Docker file M2 would be identical, but would have an extra line to have layer 3 as well, and so forth. So we generate all these Docker files, and each one of them will be used for these images, all except the pending one, which we will look at later. Okay, and then it comes the stages that the tool offers. So basically, the tool can be used as a CLI, a compiled binary that supports multiple commands, and each command will be a separate stage. Ideally, these would be separate stages also on GitLab CI, but they can be executed in sequence, all in the same stage or the same job. So they are separated in this proof of concept just to make sure that they are granular enough and allow us to execute step by step if we want to, but we can bundle this together. But let's look at them individually. And we start by the first stage, which is the generate stage. And here, as I said before, the tool will start by generating the random layers. And we can see that we already have here the digest that layer will have on the registry side, and we have the path for the layer on the file system where the tool is running. So we generate all of the layers, and then we finally generate all Docker files using those layers, as I explained before. And finally, there's this information here, and as I explained before, after executing each one of the stages, will persist the build context or the data that they have generated into a file on the file system, so that subsequent stages can read that and know the data that they have to validate or push to the registry or pull to the registry. So in this case, this is this build.cop file is just a Go data structure serialized using the encoding Go library. And then written to a file on the file system. And this will contain, for the generate stage, it will contain the lists of layers that were generated and the list of Docker files. So that's mostly the digest for the layers, the path for each one of them, and the path for each one of the Docker files as well. So we generate them, we build that information, and we save it into build.gov, so that it can be cached in GitLab CI and reused on the next stages. So after generate, we have the build stage, and here the idea is to grab those layers and those Docker files from the previous stage and build the Docker images using them. So build will start by reading the build.cop file from the generate stage, and then it will iterate over the list of Docker files and generate the corresponding images. So we can see that here it is building an image automatically with the right path and using the correct Docker files. So this is all it does. And we can also see that there is an additional piece of information here, which is the image configuration digest. So a Docker images always have a manifest and a configuration. And for each one of those, we have a digest. So when we build the images here, the Docker engine will build the image payloads, and that will lead to the creation of a configuration. And we capture the digest from that because it will be important for the future stages. So we capture that information, we append it to build.cob, and we are done with the build stage. And of course, in this case, I'm executing this on my local machine, so I'm performing the tests manually. So to make this work, I had to manually define these environment variables, which are predefined for GitLab CI. So this is only needed for a local test. And then we move on to the next one, which is the push stage. And here we will push the images that were built on the build stage into the container registry that we're using. So the tool basically starts by reading the build.cob file, finding the list of images that were built on the previous stage, and then pushing each one of them to the container registry. Now, the target container registry is inferred from the CI registry image environment variable, which contains the registry address as a prefix. So for production, this would be registry.gitlab.com. For pre-production, it would be pre.registry.gitlab.com. So there is no need to do anything besides that. And internally, we use that information is missing here, but we use the Docker Engine SDK to push those images. This is basically just the Go SDK to interact with the Docker Engine API. The alternative would be to invoke the Docker CLI from Go, like executing a shell command. This is a bit easier because it gives us a bit more control, but the effect is exactly the same. We are giving a command to the Docker engine to push the image to the registry. And when it is pushed, then the registry will give us the digest of the manifest, and we are going to save that information on the build context because it will be needed for later. Okay. And as I was saying, to interact with the registry here, we do use credentials, and those credentials come from the predefined CI environment variable. So that's CI registry user, I think, and CI registry token or registry password. I'm not sure about that, but those are already predefined on GitLab CI as well. If we are using a local registry, then most likely it doesn't have any authentication, but if it does have, we need to define those variables like we do here for registry CI image and registry CI pipeline ID. And then we move to the next one, which is pull. And here the only thing that the tool does is making sure that we can pull the images that we've built and push to the registry, just to make sure that everything was built correctly and stored correctly on the registry side. So the only thing that it does is read that build.cob file, find the images that were built, and then pull each one of them from the registry, making sure that all those pulls finish successfully. And the build context does not change in this stage. And finally, the last stage is test. And here we want to do three things. One, we want to invoke the registry API in a certain manner that will trigger some actions from online garbage collector. Then we want to sleep for enough time to let online GC workers pick those tasks and do whatever they need to do. And finally, we want to validate that the online garbage collector either deleted artifacts that were dangling, so they were garbage collected, and also make sure that stuff that shouldn't be deleted was not deleted, which is even more important. So as I say here, the required sleep time between triggering those requests and waiting to perform the validations varies per environment, depending on the registry configurations and the workload from other clients that are using that registry. Please refer to the online garbage collection spec to understand better what's involved in that process in calculating those delays. But let's not focus on that here. And to make that work, the tool provides two ways. So for an interactive validation, that would be an engineer like myself performing a test and manually validating the outcome against the, for example, the pre-prod registry. By default, the tool will wait indefinitely between triggering those requests against the registry and making the validations. So that means that once we start a test, it will make the requests, it will wait indefinitely for me to press a key on the keyboard. That should give me enough time to go and check the online GC metrics and queues to make sure that the tasks were created, processed successfully. And then when the queue is empty, I'm confident that I can press the key and the registry will do the validations when everything was already dealt with on the registry side. And for non-interactive validations, we can also pass a delay flag to the CLI, and we can give it as arguments an amount of time to wait, a fixed amount of time to wait before performing those validations. So for example, in GitLab CI, we could define an environment variable, which is different for each environment. For example, depending on the pre-prod registry configurations, we may deem that we need to wait 10, 15 minutes before performing validations in most cases. So we can define an environment variable like registry, wait, delay, something like that, and use that as an input for the delay flag when triggering this command on the CI file. And finally, for better granularity, the test stage was split in 5 substages, but they can be bundled together or can be separated, but we will look at them separately. So the first one, and we can control that with a stage flag. So stage equals 1 means that it will execute the first substage of the tests. And we start by deleting the latest tag in repository A. And when we do that, this will not cause the deletion of anything else because the underlying manifest, which is M2, we can look at the tables above to see that relation, but it's M2, and the layers that are referenced by that manifest, 1, 2, and 3, are still referenced by the tag 2.0.0 within that same repository. So the manifest shouldn't be deleted, neither the layers. So the only thing that we need to do is trigger stage 1 with the tool. We can see that the tag was deleted. This is wrong actually, but I'll fix that later. And then the tool will, by default, will sleep for enough time until I press the enter key before making the validations. So in here, I did the manual validations. I checked the registry metrics to make sure that tasks were processed. The queues for online GC are empty. So we're good. Then I press the enter key and the tool will perform the validations. As we can see here, it will look for the M2 manifest. So this is the digest of the M2 manifest to make sure that it's there because it shouldn't be deleted. And after that, it's going to look for L1, L2, and L3 to make sure that they are also there because they shouldn't be deleted. And that's everything that happens on this substage. Next, we move on by deleting the 2.0.0 tag. And when we do this, there will be no other tags pointing to the M2 manifest. This would be the last one. That means that M2 should be considered dangling and garbage collected. And once that happens, and you can understand that by reading the spec, when a manifest is deleted, either through the API or because it was garbage collected, automatically the registry will schedule a review for the layers referenced by that manifest. So that means that L1, L2, and L3 will be scheduled for review. And when done, L3 should be deleted because it is unique. It was unique to the 2.0.0 tag, as we can see here. So we can see that 3 was unique because we already deleted latest, right? And the only 2 images using the L3 were latest, already deleted, and 2.0.0, which we are deleting. So L3 should be garbage collected, and L1 and L2 should be preserved because they are still used elsewhere. So if we get back here, You see, we trigger stage shoot, the tag was deleted, slept for enough time. I pressed enter once everything was validated, and then the tool will make sure that the M2 manifest is gone. So manifest not found, that's what we want. And it will make sure that L1 and L2 are still there because they are needed. But it will make sure that L3 is gone because it's no longer referenced. Finally, we move on to deleting the manifest M3. We're not deleting a tag in this specific test case. We delete the manifest directly. And by doing so, as I said, that will cause the registry to review the underlying layers. And for the manifest M3, that's L1, L4, and L5. And out of these, L1 is the only one that should not be garbage collected because it is still referenced somewhere. But we can see here that L4 and L5 were the only ones that were used by this manifest. So M3 is used in this tag, and this tag references all these layers. So by deleting that manifest, a task will be scheduled to review this one, this one, and this one. This one is still needed by everyone else, but these two are no longer needed, so they should be garbage collected. So that's what we are going to test. Again, stage 3. After validation, I trigger the two validations, and we make sure that the manifest is gone. L1 should still be there because it's needed, but L4 and L5 should be gone. Okay, and if we need to look back to see the correspondence between digests and the layer name, we can look at the logs from the generate stage, and we can see the digest here and L5, so we can make that correlation by looking at the logs, but that should only be needed if the test fails for some reason. But everything went okay this time. We move on to the next substage, which is simulating a text switch. And a text switch, for example, happens quite frequently with the latest tag, for example, because latest is usually used to point to the latest version of your image. But of course, the latest version changes. For example, for GitLab, it changes with every release. So it will start pointing to 13.9, and now it will point to 14.0. So that's a tag switch. We are moving the latest tag from pointing to the manifest that was used to build the image for 13.9 to the manifest that is used to build the image for 14.0. So here we do something similar, but we do it with this tag. It was initially pointing to M1, as we saw before, and now we are going to point it to M4, which is a manifest of that pending image that we had before, and we didn't push the registry just yet. So in this step, what we do is we grab the M4 Docker file, we build an image with it, and we tag it with a 1.0.0, and then we push it to the registry. And when we do so, the registry will see, okay, this tag already exists, so 1.0.0 already exists in the repository hey, but it's pointing to M1. So let's switch that pointer from M1 to M4, and that's it. And when this happens, this is also covered on the spec, but when it happens, the registry will automatically schedule a review for the previous manifest that will be M1. It will detect that there was a switch, so maybe M1 no longer has a tag pointing to it. So a task is scheduled to review M1. And in this case, yeah, it's no longer tagged. We left M1 orphan. There are no other tags pointing to it, so it should be garbage collected. And as response to that, the layers referenced by M1 will also be reviewed, and L2 will no longer be referenced by any other image on the registry, so it should also be garbage collected. So we trigger the stage number 4. It does all of that, builds the new version of the A1.0.0 image, pushes it to the registry. Of course, the config digest changes, so we save that information, and then it pushes to the registry, sleeps. I do the validations, and then it will make sure that M1 is gone, L1 should still be there, but L2 should not. So everything went okay here. And finally, the last substage is deleting the last tag that we have on the registry, which is a 1.0.0. And by doing this, keep in mind that we have switched 1.0.0 from M1 to M4 here. So it now only points to L1. So that's the same manifest here. It only points to M1. And that means that if we delete the latest tag, this will cause the deletion of the last manifest, which is M4. And by deleting that manifest, it will cause the deletion of the layer that it referenced, which is L1, because there are no other images on the registry. So we trigger stage 5, the tag is deleted, the tool sleeps, I do the validations, and then it will check that the manifest is gone and that the blob is gone. And by now, all the artifacts that we have generated were garbage collected across these 5 stages. So that's the rough idea, both of the receipt. So this is an hard-coded receipt, the set of images, the set of layers, how those images are built, and also the test cases. These are fixed test cases meant to test specific behaviors of online GC. So we can always change them, add more substages to test different scenarios, add more images to test some kind of combination that we are missing. But this is the main idea. I'll just show it here quickly because I've tested this on GitLab CI quickly using this. And in this case, I've bundled I have a separate stage for generate with a single job. I have a separate stage for build with another single job. And then I've bundled the tests and build, push, and pull. So build, push, and pull were bundled with tests in a single stage, which is validate. And I only did that because it was easy, because with builds, when we generate an image using GitLab CI, using Docker in Docker, the generated images will only be local to that runner instance, to that container where the images were built. And that means I will not be able to reuse those images for the push stage because they were built in a separate job, so they are lost. Of course, we can cache built images. I didn't do them here. My only purpose here was just to make sure that this was feasible to execute on GitLab CI. And yeah, we can see how it works, generating the layers, the Docker files, persisting the build context, then carry on with the next stage, in this case build, generating the images, and I've gone to the push here. So build and push happen both on this stage. So we build and push the images, we update the context, and you will see some differences on the logs because I already made some changes to the tool that are not shown here on the pipeline. And then finally, it will pull the images and will perform the tests on the validation. And yeah, that's all. What are your thoughts about this?
Yeah, I think this tool is awesome, and this is great work, Jean, because I'm just really thinking on how to plug this to the existing pipeline, running this again against preprod. So when you run this generate, build, validate pipeline, you are running in the container registry repository, right?
Mute myself. Yeah, I've used the container registry repository for this because it was the easiest way to create this POC because everything is set up already. But if you see here, I actually, let me collapse this. I actually erased the whole container registry GitLab CI file and created a couple of customizations. So for example, here you can see that I'm caching the build context, I'm caching Go modules, and then we can see that I have the variables defined here. I have the 2 stages, generate and build. And then for each one of them, I'm going to run the tool, In this case, I run it from source, but it could be compiled and run it like that. So yeah, you can basically separate each one of the stages that I documented here in separate stages for GitLab, and then use one or multiple jobs to execute them.
Yeah, I see this as, so basically, as far as I can understand with our existing pre-prod pipeline is, we could incorporate this GitLab CI inside of the tests, as we are doing already for container registry tests. When we do Docker build, Docker push, we would incorporate this tool, and then we would have that pipeline inside the test that would go through all those stages and verify if they are passing. But I'm thinking that how would we do with just give me a little bit more about that interactive mode. Would we still be able to get something of this test even if we don't get to press the keys? I didn't get maybe that part.
Yeah. So by default, and let me show it here. You can you read this?
Yeah.
So I'm going to run it from source. I could have compiled the binary, but that doesn't matter. I'm running from source. And here, for example, let me just remove everything that I've built so far. And let's trigger the generate stage once again. And test build. Let's just go through each one of the steps very quickly so that you can have a view of how it works. Build, push. Of course, this would break during the demo.
Yeah.
Okay, so you can do tests, and then you say the stage 1, and by default, this will, of course, there is no text left to delete, but this will wait for me to press a key to continue, as I shown on the logs. But if you pass this, like 5 minutes, it will not wait for me to press a key. It will automatically wait. It will sleep for 5 minutes and then continue with the validations. So for GitLab CI, we could do something like that. So here,
have a CI variable.
Yeah,
right?
yeah. And here we would have well, in the test we would have a separate argument which would be delay set with an environment variable that has a viable delay for that specific environment where we are running those tests. Yeah. And there would be no manual intervention from anyone. We just have to make sure that that delay is big enough to let the registry deal with the test that it has in hand.
Yeah, and each test, just to see if I got this right, each test stage has a weight of delay, right?
Yeah.
X delay.
Yeah.
Is there a way that we batch these, in a way that we could wait that time just once?
Yeah, we can do that. For example, we could run all triggering operations like deleting tags, deleting manifests, blah blah blah, for all these substages in bulk in a single operation, then sleep once, like for 20 minutes or so, and then execute all the validations from each one of the stages. So here I've split them so that it's easier to understand if you go step by step. And it's
we could even parallelize them in a way. I think it would be possible if I'm not really sure if that would be a problem to just parallelize this.
It would, it would likely be a problem because, for example, if you're parallelizing the deletion of 2 tags, that point to the same manifest, in one of them you are going to assume that there are no tags left for that manifest, but that concurrent pipeline maybe hasn't executed yet. So it's better to make sure that these are sequential, either split like this using the stage flag, or executed one after the other without intervention, but make sure that they have a fixed sequence, because otherwise it won't be deterministic.
Yeah. So perhaps we could go with the fixed sequence instead, just so we don't have like a 3-hour pipeline, not 3-hour, but yeah. So as I see, I think this is possible as long as we have access to the tool, the binary from the command line. There is a way that we can install it and then run it. So even if we import, because I see that you have online GC tester / main go. So there is like some files from this tool.
So we can do this in multiple ways. As I said, I have this on the container registry repository. I'm not sure if it should stay there or not, but it's the easiest place to start with. So we can do this in multiple ways. So we can fetch the registry repository as it's done right now, fetch the container registry Git repository and build the binaries from source, and then we can execute them like I have here. So dot and the name of the binary, or we can just fetch the Git repository and execute them like I'm doing here. So calling the main file for that binary and execute it. It takes a bit more because it has to compile the code. So it's better to build the binaries, and that should be easy. Fetch the Git repository, execute a make task, which will create the binary, and then you will have the binary available to you in the bin folder. The alternative would be to do this using a Docker image, where you on the CI, instead of using a base image of Golang or Ubuntu or whatever, you would use an image that already has the binary there. That we will have to do is execute the binary, and that's it. So there are multiple ways to do it.
I'll probably start by doing the same way that you have here for the container registry project. And I think, like, are we going to keep this tool within this repository? Do we want to separate this somewhere, or it's just
I'm not yet sure about that. We should ping Ellie as well to see what she thinks about it. Right now, it makes sense to be on the registry because it's related to the registry, but at the same time, we're doing something that's not related with the registry operation as a service. So it's more a tool on top of the registry. So it might make sense to pull it from the registry and have it somewhere else. I don't know if there is any dedicated group for quality tools. Use it for
we have a few quality tools. I think perhaps this could be a candidate to be stored there. Perhaps maybe not now as we are doing the POC, but something to consider later. And I'm thinking that this is not intended to be running in any GitLab CI container registry release, right? I know that there are some tests for Go versions, for example, but this is not meant to be run then. This is just to be run against preprod, right?
I think we will run this manually in the interactive way when we change something about online GC, and we want to make sure that it is okay in pre-prod, for example, before going on with the production deploy, or then have it automated in the QA pipelines in pre-prod as well, and run after each deployment to pre-prod. So I think those are the only two use cases.
Right. One thing, when you're doing the test validations, I only know very few Go still. When you do test and then main Go, you have the information that you're outputting. This is logs, but the validation is happening as well, or do you have to actually verify this output yourself in order to really validate results?
No, the validation is happening automatically. So for example, here when they delete the tag, it will sleep or wait for my click, and then it will perform a fixed set of validations. So the tool, I can show it to you. the code is terrible, as I said. So, but yeah, let's see tests, and here we can see it will break tests in multiple stages. And for example, for the stage 1, it will load the build context. Then it will build a registry client in Go. Basically, this is just a Go client for the registry HTTP API. And then we are going to invoke the API using this client to delete the tag. The tag was deleted. And then we are going to perform the validations here. So we want to make sure that the manifest still exists or not. And we also want to make sure that blobs exist or not. So we do those validations here automatically. So the job will either succeed if all validations were okay, or it will fail with an exit 1 status like it did here, if something goes wrong. So the CI pipeline will either succeed, and then we know that online GC is okay, or it will fail and we need to investigate what's going on.
Okay. I think by the end of today, hopefully I could already have something, an MR open with all of this integrated, and then we could try to run this against pre-prod and see what happens. And where can I find this documentation? It's in the container registry docs, right?
I just finished writing this just before our meeting. So what I'm going to do, I'll push the minor few changes that I did on the code to the branch. I'll add this document there as well. And for now, we'll not merge this to the main branch until we know if this is going to stay here or in a separate repository. So to test it, we can just fetch the repository, the specific branch from the registry repository, and go from there. I'll add this into the docs folder, docs GitLab folder. So it will be here. This document that I have here, I'll place it here, and I will also add a make task to compile the online GC tester binary so that it is available in the bin folder. So the only thing that you have to do is pull the registry Git repository and this specific branch, run make build, and then in ./build/folder, you will have the online GC tester binary done there. And then when it comes to the rest of the code, as I said, the code is terrible and is far from complete. As we discussed it before, I think you're learning Go as well. And being this is related with tests and probably you want to extract this from the registry repository, I think it can be an interesting challenge for you as well.
Definitely, and also if we want to continue adding cases for this, it would be good. So regarding the settings of container registry garbage collection in pre-prod, which modifications are we going to do to the registry, and when would we reasonably set the delay at? Would it be 15 minutes? Would it be 5? When can we actually have this adjusted in pre-prod?
Yeah, so that's the tricky part that can lead to that non-deterministic behavior that we have been discussing. So it's not impossible that we will have some false positives or negatives, but we have to give it a try before giving up. At least we should do that. So in pre-prod, what we need to do, we need to tweak a few settings. So the first one that we need to tweak is the review after, and this is going to define the amount of time that will be used to postpone a review. So for example, when you delete a tag, we know that a review will be scheduled for the manifest that was below that tag. And by default, the registry will schedule that review for 24 hours ahead. So if I delete it now, the review will only happen after 24 hours. So for this test, we need to make sure that that happens much quicker, let's say 5 minutes, but we can't make it too small because then there is the possibility of garbage collecting stuff like on ongoing image uploads Think about an image that takes like 10 minutes to upload. It's not impossible. It might happen. If a blob is pushed, a task will be scheduled to review that blob, and that blob will remain untagged, possibly untagged, until the very end of the image push. So when it gets to the final part of the image push, it might fail because the garbage collector already removed one of the layers that it was supposed to use. So, but it's pre-prod, it won't be used that much or not at all. So I think it's fine to lower this, like say 3 minutes, 5 minutes. We can start like 3 minutes, 5 minutes and see how that goes. And then the other thing that we need to do is turn this flag no idle back off to true. And this is because OnlineGC is a backward process. It runs in intervals. Let's say 5 seconds. Every 5 seconds, the worker will kick in to see if there are tasks to be reviewed or not. And if there are no tasks to be reviewed, instead of keep hammering the database every 5 seconds, by default, the garbage collector will back off exponentially when there are no tasks to be done. Like if there are no tasks to be done now, instead of running in 5 seconds, we will only run in 10 seconds. And each time it will take more and more time if there are still no tasks to be deleted. So we want to turn that off so that we are sure that the worker will run successfully, will run sequentially every 5 seconds or so. And the other one is the review interval, the kicking interval, which by default is 5 seconds. So that should be fine. We can lower it, but 5 seconds should be enough. That means that every 5 seconds, the GC workers will look for available tasks for review. So we need to take that into account as well. So 3 settings: the review interval, the review delay, and disabling backoffs in case of no tasks available.
Okay. I'm going to mark this set of tests as allowed to fail, just because in the beginning, while we are fine tuning this, we might just be getting. I believe that we're going to have a Slack report in the pre-prod channel. There is a channel where we're already running every day. We're running tests in pre-prod, so there would be an additional notification there with this jobs. And it's going to be marked as allowed to fail for the beginning. And I have another one thing that we can consider is, so right now they are going to be scheduled, but I was checking the infrastructure code for delivery, and I found out where they are triggering in the deployment path. So later on, perhaps once we want to make it as, I'm not sure if it's going to be every time the container registry releases, we want to trigger this. It's also possible. It doesn't seem like such a big change, but so we are going to start with a scheduled test. So every day or every 2 times a day, we're going to be running this garbage collection tests. Not sure if I hope it doesn't. Maybe if it's just 1 time a day, it's going to be enough. Unless we want to adjust.
I think the way to go is trigger that pipeline right after the deployment to pre-prod, so that we can wait for the deployments to staging and production for that pipeline to finish successfully before moving on with the deployments to staging and production. But yeah, to start with, it's better to make this an unblocking failure and possibly manually trigger it. It's probably easier, right? Go to the UI, trigger, test, and see how it works until we are confident that this is feasible, mainly due to the non-deterministic, the possible non-deterministic behavior.
Sure. So I think I'll be able to get back to you in a couple of hours just with something, and then we just comment in the MR and go from there, if that's okay.
Yeah, I'll push the changes and the doc, and I'll also ping Ellie on the MR and you so that we can discuss a bit where this should live. And then we can continue with the integration for QA tests, and even if you want with pairing or an end of to work on the code, move this to somewhere else, make it better, implement it properly, because as I said, this is poorly implemented right now.
Yeah, okay. Sounds like a good plan. Anything else you'd like to add?
No, I'm going to share this screen on Slack and also on the issue for online GC tests. But yeah, I think that's all. Thanks
a lot, John. This is really good work. Really, such a good tool for this case. Yeah.
Thank you.
Okay. Bye bye.